Hello everyone, welcome back. So right now we have an interesting session which is combining Django ORM and FastAPI in a single app by Mia. She's right here to deliver the talk. Welcome Mia, the stage is yours.
Hello, everyone. I am Mia Bajić. It's my first time both in the US and at PyCon, and I'm very happy to be here. Today, thank you. Today, I'm here to tell you an intriguing story about working with a code base which has blended two quite different technologies together. I'll share my personal insights on how to navigate through it, highlighting the advantages, struggles, and lessons learned along the way. I am a software engineer. Currently, I'm working at Atacama, where I create data products. I am based in Prague, Czech Republic, and I co-organize many community events, such as Python Pizza, EuroPython, PyCon, and Pivo. I'm passionate about all things community. Now, let me share with you my previous experiences with frameworks. The first framework I had experience working with was Flask. I used it for my hobby projects and for my diploma thesis. What I like about Flask is that it's very lightweight and flexible. It's also simple and easy to use. Then, I began working for a company that used Django. Django is a batteries-included framework, which was great for the apps we were making, as it did not require any configuration, had all the things we needed, and worked well out of the box. And finally, I joined my current company where we use FastAPI, but in an unconventional setup I will talk about later. These three frameworks are currently the most popular ones in the Python ecosystem. According to a JetBrains survey from 2023, Django leads the pack, used by 40% of responders, followed closely by Flask with 38% and FastAPI with 25%. However, the interesting fact about FastAPI is its rapid growth and its huge adoption, rising from 14% in 2021 to 25% in 2023. Now, I'm curious about your experiences with frameworks. How many of you have experience with Django? Raise your hand if you have experience with it. All right, so it looks like around 80% of people. How many of you have experience using FastAPI? Okay, around 50%. And now comes the fun part. How many of you have experience using both Django and FastAPI in one application? 3 hands, okay. This was expected. And indeed, if you have a look at the most popular open source FastAPI projects on GitHub, you will notice that none of them use Django ORM. Most of these, in fact, use SQL Alchemy. Now, you might be wondering why. Why is Django ORM not a popular ORM of choice when working with FastAPI? To find out, let's dig deeper into each of these two frameworks. FastAPI is a newer framework released in December 2018. It's very modern and very flexible. It's built on the shoulders of two giants, Pydantic and Starlet. Pydantic is a Python package used for data validation, serialization, and documentation. Starlet is a lightweight asynchronous framework or toolkit used for building web services. That means that any of its components can be used independently. Its main features include WebSocket support, session and cookie management, a task client, CORS, gzip compression, static files, streaming responses, background tasks, and many, many more. As you could notice on the diagram, Starlet uses UVcorn and implements SGSpec. The most notable feature, or the feature for which it's best known, is its performance. FastAPI is one of the fastest Python frameworks, and its exceptional performance is largely due to asynchronous capabilities. Django, on the other hand, is a framework with its first release in 2005 and has been the most popular framework for years. It is a batteries-included framework, meaning it comes with a comprehensive set of features right out of the box. Additionally, it is quite opinionated. as it was designed to promote specific patterns and approaches to web development. Its ORM is primarily synchronous. Asynchronous features have started to be added from version 4.2, which was released in April 2023. However, full implementation of asynchronous feature is still ongoing. Now, the question is, what are the benefits of using Django ORM together with FastAPI? From my personal experience, Django ORM is easy to learn. I switched to Django ORM after using SQL Alchemy, and it feels like Django ORM is more high-level, so there are fewer things one needs to take care of. For example, you don't need to take care of session management, while in SQL Alchemy, you do. I have experience with Alembic and Django migrations, and I find Django migrations easier to learn and easier to manage. Also, Django has a very rich ecosystem with lots of tools that you can use. If you type Django on PyPy, you are able to find over 10,000 of packages containing the word Django in them. If you head over to djangopackages.org, you can find lots of different projects to explore. FastAPI is a relatively new framework, therefore its ecosystem is smaller. One of the killer features of Django is its admin panel, where you can add, delete, or update data belonging to any model. It's a user-friendly graphical interface, so it can be used by users who are not programmers as well. FastAPI doesn't have a built-in panel, so if you want to have one, you have to use third-party packages. Django is also well-maintained and supported by a large and active community. This community not only contributes to the framework's development, but also organizes events like DjangoCon, where developers can gather together. DjangoCon also includes sprints, where everyone has an opportunity to contribute to Django. I personally have been to the sprints, and for me, it was an amazing experience to poke around the codebase and to learn how Django works under the hood. Django also has great documentation, where you can find tons of resources and support online. There are forums, tutorials, Discord groups, and even podcasts all about Django. If you want to check it out on your own or connect with the community, head over to djangoproject.com/community. This is one of the things I'm personally a bit missing with FastAPI. It's a newer framework, so the community is not so big. If we take it from the other side and ask ourselves, what does FastAPI bring to the table, and what are its benefits comparing to using Django? The biggest reason you probably want to use it is its improved performance thanks to its asynchronous capabilities. FastAPI also includes a powerful feature that automatically generates documentation for your API endpoints. This interactive documentation, provided in the OpenAPI format, simplifies the initial setup. If you open your app and navigate to /docs, you can explore and interact with your API directly. Alternatively, if you prefer a different style, you can use /redoc to view the documentation in redoc format, which also utilizes the OpenAPI specification. FastAPI utilizes a nice feature called dependency injection, which really helps keep your code clean and testable. In order to see how it works, let's see an example. Let's say we have a service that fetches data from an external production API. We have a route that utilizes this service. Each time the endpoint /fetch data is called, an external call is made. Now, how can we test this without actually calling the external API? Here's an example of what our test might look like. First, we create an async mock object that has a return value. If we want to swap our dependency and use the async mock instead of the production service, we can call dependency overrides. Then we proceed to test our endpoint as usual. In just one line, we manage to swap our service with another. This is a nice pattern that improves testability. I'm not seeing this pattern being commonly used in Django. The last feature of FastAPI I want to highlight is its simplicity. Sometimes working with Django can feel like there's lots of magic happening under the hood. This might be helpful initially when you're trying to quickly get something up and running. However, it can also mean that everything works fine until it suddenly doesn't. And then what? Then you start debugging. And sometimes it's hard to figure out what's going on. FastAPI has a straightforward approach, and it makes it easier to understand how your application is put together and how it works. And that can be a huge advantage when troubleshooting. Now, I told you lots of benefits from using these two frameworks together, but there's a reason why this combination is not commonly used. Let's explore some of the unique challenges it presents. The first thing you notice, you start working with a code base that mixes synchronous and asynchronous code, is how often this exception happens. And it happens in places you didn't even know existed in your code base. How many of you working with Django have ever seen this exception? Okay, 3 people, not so many. If you decide to use both Django ORM and FastAPI, you're almost guaranteed to run into it sooner or later. One of the big reasons why I believe this setup is not commonly used is because managing synchronous and asynchronous code adds another layer of complexity you have to take care of. Let me share a quick story called There and Back Again. When I joined the team about 1.5 years ago, our code base was sync first. This meant all methods were synchronous. For asynchronous functions, like in API routes, we use sync to async decorators. I witnessed a situation where my colleague was working on rewriting the whole code base to an async-first approach. Back then, Django had released support for async ORM, and the idea was that now, when everything can be async, why not test it out to see if it's easier than having it half sync, half async? The change initially seemed successful. However, the devil is in the details. While Django has added lots of async features, there were many features that it still doesn't support, like async transactions. So everything had to be returned back. One of the great features of Django that I already mentioned is its very rich ecosystem. However, these tools often don't work with FastAPI. There are cases where these tools don't work at all. For example, I tried to use PyTest Django exist to speed up the tests, and it did not work, as FastAPI uses Starlet's test client, and that one is different from the Django one. Some of the tools do work, but they have to be tweaked, meaning they don't work out of the box, as they would work with Django. When you encounter a problem, what's the first thing you typically do? You Google it. However, if you run into issues with this particular setup, you will find that there are not many examples or resources available online to help you. So you're left on your own, and you have to experiment. The last point I would like to touch on is the initial setup. With Django, you can simply use commands like start projects, and you're ready to begin. Similarly, with FastAPI, a few lines of code are enough to get things moving. However, with any custom setup, especially when you're combining unusual elements, it will inevitably take more time to get everything up and running smoothly. Now, let's explore how this setup might be implemented. First, let's have a look at the diagram. We have a FastAPI application that utilizes Django ORM for database communication. Where should we start? We are integrating 2 different frameworks, so we must configure them separately. We begin with Django and its database layer. First, we modify the settings.py file used by Django. I've only changed the database name, everything else remains unchanged. Next, we need the wizgy.py file to import the Django settings module and launch the application. Now, let's turn to our main.py file where we consolidate everything. Here, we set up the Django settings module, call Django setup, and populate the apps with our installed apps. Now, Django is ready. The second part involves setting up FastAPI. We start by creating a FastAPI app instance. Then we define routes and connect them. For deployment, I prefer using Docker. The Docker file specifies our base image and working directory. Then we copy our requirements, install them, copy all necessary files, and expose port 8000. Finally, we launch the app using Uvicorn, specifying our main file, host, and port. If we now open localhost and type in /docs, we can see it works. Moving on, how do we create an endpoint that lists some data stored in a database? Let's see an example. First, we define our endpoint path, add some description and response model using our pydantic model. Then, we make a database call, which is wrapped in the sync to async decorator. It's a coroutine, so we must await it. The fetch data is then serialized as a pydantic model. For Django versions above 4.2, you can use aget directly without the decorator. The implementation manages synchronous and asynchronous code under the hood by using the same decorator when necessary, so you don't have to take care of it. However, keep in mind that while Django has added many async features, it is an ongoing process and not everything has been implemented yet. When you call the endpoint, you will see the data return. Now, let's move on to tests. The principle is the same as for setting up our main app. First, we need to set up Django. We do this by defining where our Django settings module is, populating apps, and finally running migrations before each session. Because we want the database to be clear for each test run, we need to create a fixture which truncates all tables after each test run. Then, we move on to the second part of our setup, which is the FastAPI side. We create a fixture where we basically import the app as is. The last part involves setting up a client to which we pass our imported app, and we configure its base URL. Let's look at how we can create a test that evaluates the creation of a model. First, I would like to show you how to set up a unit test. Our test will assess a service method that adds a new book, and it will do so without a database. Our fake repository might look something like this. Instead of persisting data into a database, we store it in an array, which we can access later. We start by creating a request with some data. Then we call our book service, but instead of using its normal repository, we use a fake one. Next, we call the method and pass the request data. And after that, we can access the array where the data is stored, and we can assert whether the stored data equals the data from the request. If you would like to write an integration test to test your entire endpoint and use a database, you could write it like this. First, we create our test that uses a database fixture that takes care of truncating tables, sets up the books app, and includes a client fixture. It also uses the fixture books, which creates some books just so to have some data to test on. We call the endpoint books and assert that the response code is 200. We can also define the expected data and then compare the expected data with the received data. And that's how you could set up tests. We've seen how it might be implemented, but you're probably now wondering about the right structure. If you start off with Django, you will find that the structure is already set up for you. That's because Django likes to guide developers with certain best practices, including a predefined structure. FastAPI, on the other hand, is super flexible and doesn't really push you in any specific direction regarding how to structure your project. When it comes to bigger projects, I personally lean towards a module-based structure. It's predictable and extensible. Take, for example, Netflix project Dispatch. It's one of the biggest open source FastAPI projects I've stumbled on GitHub, and it uses the same structure. This kind of structure is also mentioned in FastAPI best practices repo, which I'll link to a bit later. And this structure works well even if you're using Django ORM. All right, so we've discussed the benefits of this setup and its challenges. I've shown you how it could be done. But the question remains, should it be done? I personally love working with both frameworks. However, if I were to start a new project from scratch, I would probably check out Django Ninja as it gives you the best of both worlds. Alternatively, I would go either full Django or FastAPI with SQL Alchemy, depending on project requirements. It might happen, though, that you find yourself working on a project that has already integrated two different frameworks together, like me. Or you're maybe migrating from Django to FastAPI, beginning with the FastAPI layer. In these situations, I encourage you to experiment with mixing technologies. It's lots of fun because you learn a lot during the process. And I'm really interested in hearing about your experiences. Have you ever tried mixing different frameworks? How does it work for you? I'll be here around today and tomorrow, so please feel free to come and talk to me. And to quote my esteemed colleague who joined our team and expressed this during our first retrospective meeting, "It's crazy, but it works." I'm Mia Bajić. Thank you for your attention. Yeah, sure. Yeah, so now it's time for Q&A. If anyone has questions, please go behind the microphone is over there. There's the second one.
Hi, thank you. Great presentation. You mentioned Django Ninja. Could you say a few more words about Django Ninja versus Django and what it offers?
Yes, so Django Ninja is a newer framework. It was released at the end of 2021, and basically it bridges the two worlds between FastAPI and Django. So basically it's like Django, but they're with asynchronous capabilities. Do we have any more questions?
Thank you for talking to us. I know one thing I was thinking about is you said you'd go with like Django Ninja. I guess like when you think about what you're working on over the next 2 years, could you talk a little bit more in detail about when you would reach for FastAPI as opposed to Django for something that you might be speccing in the next year?
Yes, so as I said, I think it really depends on project requirements. I personally think Django is great when you are creating crude apps. And I work for a company that was creating like typical apps, which are everywhere, and Django was great because it had lots of tools, everything worked out of the box, and we didn't have to tweak anything, so it was really helpful with the initial setup. And also there are lots of tools in Django ecosystems which we could use as is. At my current work, the reason why we use FastAPI is because for us the most important requirement is performance. It is a data visualization tool that works with real-time data, and we need it to be fast and performant. So the reason why FastAPI was chosen is just because of performance. Of course, it depends, I think, what your main requirement is. If your main requirement is performance, I think frameworks like FastAPI or in general asynchronous frameworks might be better. But if it's something which is not really important for you and you're creating some typical apps, for example, I think Django might be good as well. Thank you. We have one more question. Yes.
About dependency management. Did you ever have any conflicts, since they're both large frameworks, in trying like to update one of the frameworks and it ended up breaking something to the other framework or the other way around? Not sure if you ever had that scenario.
Yes, so we haven't had any conflicts, and that's because these two frameworks are not connected together. So we have different layers. We have the database layer, where we use Django ORM, and then we have API layer, and these two layers do communicate with each other, but these tools are not connected to each other. So we haven't had any conflicts, but it is an unconventional setup, meaning things don't work out of the box and you have to tweak it a lot. There are also different ways how Django ORM works with session management comparing to SQL Alchemy, which is the most commonly used with FastAPI. And that was actually one of the reasons why Django Ninja was created, because there was a bug that, because Django uses signals, and there was an issue, there was a bug that the connection was closing, and that was one of the reasons why Django Ninja was created. In our setup, we have at work some infrastructure setup which is given as is, and we also had a different issue. We had the issue that the connections were staying open. And we had to, my colleague just wrote some decorator which basically closes all connections after a request, because we didn't want to have hanging connections, because we use AWS, and if you have any hanging connections, then they charge you for it. So here and there you stumble upon these things which are solved if you use some like typical setup, for example, Django with Django ORM or FastAPI with SQL, Alchemy, or even Django Ninja has these problems solved, but if you have any unconventional setup, you will have to tweak things a lot.
Perfect. Thank you.
You're welcome. Do we have any more questions? Looks like we're done, so thank you very much for your attention.